Okay, so guys, welcome to today's lesson. So we're on to 5C, which is an introduction to the unit circle. Now today's lesson will be a little bit different in that we're going to make an argument here together. That's why I've left this page blank where it says what is the unit circle. So we're going to be going through what the unit circle is here together, and then we're going to fill in a blank one, and then we'll be able to answer some of the questions from 5C for it. So, well, you've got your pens out. We're going to basically copy down what we write. We're going to talk through the argument we make for what the unit circle is. So the first thing we're going to do is we're going to the unit circle. It's a circle on the Cartesian plane that has a radius of 1 unit and a centre 0, 0. So that's going to be our first description. Okay, so the unit circle is a circle on the Cartesian plane with centre 0, 0 and a radius of 1. A radius of 1 because it's a unit circle. And then what we'll do is we'll just sketch a small unit circle. Here's our Cartesian plane. We've got a circle that has a radius of 1 and its centre is 0, 0.
Do we draw that on it?
Yes. Okay, next what we'll do, we'll just draw a few coordinates in, alright? Firstly, we know the coordinates here are 0, 0. Now, if our radius is 1, our radius is 1 unit, can anyone tell me what the coordinates are of this point here? Very good. X is 1, Y is 0. How about up here?
0.
Very good. 0, 1. And then we have just minus 1, 0, and 0, minus 1. Okay, those are our coordinates on the Cartesian plane. Excellent. Now what we'll do, this is where the unit circle comes in. Consider point P on the outside of the unit circle. Its position is dictated by the angle theta. Okay, so I'll let you write that down and then we'll draw that on there. Very good. Now we could draw point P anywhere on the outside of the unit circle. We're going to put it anywhere in here. I'm going to put it there. That's going to be point P, right? And it has some coordinates. It has an X coordinate of X and a Y coordinate of Y. We don't know what the coordinates of point P are, but I've said its position, where it is located, is dictated by the angle theta. Now what that means is if the angle gets bigger, point P would move that way. If the angle got smaller, point P would move that way. And if it's at 1, 0, that's an angle of 0. Okay, so if it gets bigger, it's moved, as the angle increases, it's moving that way. Alright, so if I moved point P to there, what would the angle be? 90 degrees, very good. Okay, so we know 90 degrees, 180, 270 and 360 degrees. We could rotate it the whole way around. Okay, now we've got, what we have here is a right angled triangle. So we're going to, Harry, we're going to abstract that triangle from our circle. And it looks like this, doesn't it? We have an angle of theta here. And does anyone know what the length of my hypotenuse is in this right angle triangle? 1, isn't it? We know that the radius of this circle is 1. So when I pull that triangle out of the circle and just sketch it freehand here, that distance is going to be 1. Okay, really good. Now, we're interested in the x coordinate is going to be the distance along there. So we'll put an x here. And the y coordinate is going to be the distance along here. So we'll put a y there. Okay, now let's label our triangle like we would do if we were doing right-angled trigonometry. This is our hypotenuse, the longest side. It's opposite our right angle. There's our right angle. This is our adjacent side. It connects theta and the right angle, touches both angles. It's next to both angles. And this is our opposite side, in that it's opposite the angle theta that we're provided with. Okay, so we have labelled the triangle. Now, if we are trying to solve for x and for y, okay, let's solve for x first. Let's solve for the x coordinate. All right? So for the x coordinate, we would have a and h. Now let's remember those 3 trig ratios. We did a recap of this on Monday, SOHCAHTOA. So if we're looking for the trig ratio that involves a and h, that's going to be cos. So we would have cos of theta is a on h. That's true by definition. Okay, that's the definition of cos. Cos theta is a on h. Now we have x corresponds with a, so we'll put x where the a is. And we have h corresponds with 1, so we'll put a 1 where the x is, where the h is. Now if we simplify this, x divided by 1, that is just x. And this is revolutionary. What we have is we have the x coordinate for any point on this circle is cos of theta. Alright, so let's write that out. X equals cos theta, and we're going to draw a box around it. The x coordinate for any point on the outside of the unit circle is cos of theta. Alright, doesn't matter the size of the angle. We can have the angle dictates its position, and so we can find the x coordinate based on the size of any angle. Let's repeat it for y. So if we want y, we've got a ratio involving O and H. O and H. That's going to be sine, right? Sine theta is O on top of H. So what that's going to give us, O corresponds with y. H corresponds with 1. We'll simplify this. We'll have sine theta is equal to y. And again, we've discovered the y coordinate for any point on the outside of the unit circle is equal to sine of theta. Okay, really good. So this is the 2 definitions we're going to take away. X equals cos theta, y equals sine theta. Okay. Now, if I go back to this triangle, we'll unpack 2 more definitions for you. The first, let's do this one first. We have tan theta is equal to O on top of A. Now, O corresponds with, I've just rubbed it out, sorry. O corresponds with Y, and A corresponds with X, right? So we would have tan theta is Y on top of X. Very good. Okay. Now here we have the definition of tan, because we have y is equal to sine theta. So we're going to plug that there, and x is equal to cos theta. So we have the definition of tan theta, it's equal to sine theta divided by cos theta. It's an important definition. That's what tan theta is. Okay, so far we've unpacked from this circle, we've unpacked 3 identities. There's 1 more that we're going to have a quick look at. Now, based on this triangle, right, we can, if we were to do Pythagoras theorem, we would have x squared plus y squared equals 1 squared. So let's write that out. x squared plus y squared equals 1 squared. But we know x is cos theta. And we know y is sine theta. And so we have the Pythagorean identity, that cos squared theta plus sine squared theta equals 1. Now the way we will technically express that is cos squared theta, sine squared theta. Okay, that's going to be the Pythagorean identity. Okay, so we've got 4 identities there. Make sure you've drawn a box around all of them. Cos squared theta plus sine squared theta is 1. We have x is cos theta, y is sine theta, and we have the definition of tan theta. Okay, so that's what the unit circle is, and now what we're going to do is fill it in for the values that we're provided with. So the first thing we'll look at is, are there any questions about any of this so far? So on the opposite page there, you have a blank unit circle. Now I'm going to sketch it here. I might sketch it a bit bigger so we can fill it in. And I'm going to prompt you with how we're going to fill it in. Clear that up. Okay, so the first thing that we will fill in is the degrees. Alright, so we're going to start with the first line drawn here. And you can see if you follow it along, we have a line here, then we have another line here with degrees written above it. So that's what we're going to start filling that in. Okay? Now basically this one here is going to be 30 degrees. So let's put 30 in there. Okay, and then the whole way around the circle, it does multiples of 30 degrees. There's one in the middle here, that's going to be 45. And then I said the next one's going to be the next multiple of 30 degrees. So we're going to go 30, 60 degrees. Okay, obviously here is going to be 90 degrees. All right, now we're going to keep going around the outside of the circle. We have multiples of 30 degrees and we have multiples of 45 degrees. So if we have the multiples of 45, we would have 45, 1 times 45, 2 times 45 is 90, 3 times 45, that one over here is going to be 135 degrees. Okay, here you've got your 120. All right, I'll let you guys keep going with the degrees the whole way around the circle. Okay, so we've been the whole way around. Yep. So all the way up to 360 degrees. Nice work. Gee, they're brownie. It's still hungry. Italian tongue. Service. Walk around survey. Okay. So even if you're not finished, that's okay. There'll be plenty of time towards the end of the lesson to fill it in. What we're going to do next is we have the degrees. We're going to also list the radian conversion. So we learnt in 5A, which was our lesson on Tuesday, that there are 2 types of an angle. There's degrees and there are radians. And in order to convert from degrees to radians, we multiply by pi on 180. Okay, so that means we're going to go the whole way around our unit circle, filling in the radian angles. So I'm going to go 30 degrees times pi on 180, I will get pi on 6. 45 degrees times pi on 180, I will get pi on 4. Alright, so let's do our radian conversion. And I'll pause and I'll give everyone a bit of time to do it. So even if you're not finished That's fine. Again, there'll be more time at the end. So far we've filled in the radians and we've filled in the degrees. Really good. Now, we also know some of the coordinates already. In fact, we know the coordinates here are x is 1, y is 0. Now, we can confirm that. Let's use our calculators to confirm that, right? We have x equals cos of theta. Now, there are two ways we could describe this position. I've got them both listed here. One would be that it's an angle of 0 degrees because you haven't started a rotation. And the other would be that it's an angle of 360 degrees. Now, let's try this in our calculator. If we put in cos of 0, all right, the x coordinate when the angle is 0 is 1. Cos of 0 equals, when you put it in your calculator, 1. All right. Similarly, the y coordinate, y equals sine theta. So if we put in sine of an angle of 0, all right, our result will be 0. Okay, the y value is 0, the x value is 1. Okay, so what we're going to do then is we're going to put the rest of the coordinates in. Now, probably the most effective way to do this is going to be just do the x coordinates first. All right, so for example here, the x coordinate is going to be cos of 30 degrees. All right, cos of 30. Here, cos of 45. Here, cos of 60. All right, so let's put the x coordinate in first. When you finish the x coordinate, we'll stop because I want to do it a little bit different for the y coordinate.
Do you have to put it in brackets?
No, you do not have to use brackets in your calculator. Yep. So you can just press sine 0. Correct, yep. So for cos
Wait,
of
why did she
30,
get that as well?
root 3 on 2.
What is happening?
Wait, do I do that for?
Yes, we express it exactly. Must be expressed as root 3 on 2, not a decimal. Issue a different approach that's going to help us generate the same answers. So let's just suppose for now we're done with x. However, we're using two types of angles, right? We've been using the degrees. Now for this unit, we need to know how to swap between the two and when to swap between the two. Now right now, we're going to start using radians. So we're going to go to our main menu. We'll go to Shift, Menu. And if you scroll down the bottom, there's an angle section. We're going to set that to radians, all right? Because now we're going to use our calculator. We're going to input radians. All right, we have two ways of measuring the angle. So let's suppose we've done the x and now we're moving on to the y values, the y angles. Well, we know y equals sine of theta. We've changed our angle to radians. Okay, so I'm up at 30 degrees, which is the same as pi on 6. I'm not going to put sine 30 in my calculator because I've changed the setting to radians. Instead, we're going to put in sine pi on 6. Okay, so sine, now we will need a bracket this time, or we just need to make sure we express it as a fraction. Sine of pi on 6, and we'll get positive half. Okay. Here, sine of pi on 4, we'll get root 2 on 2. Okay, go the whole way around the circle, fill it all in, and we should have a pretty complete circle by that stage. So one more instruction, and I think this one we'll sort of do in a different colour. Now, what we should remember is that tan theta is equal to, we wrote it on the previous page, sine theta divided by cos theta. It's the y value divided by the x value. Now this means we can find out what is the tan values all the way around the outside of the circle by doing the y coordinate divided by the x coordinate. Now, We can type that in our calculator, right? We have, so let's do it here for tan theta for 30 degrees. We can have tan of pi on 6, tan of 30 degrees, is equal to sine theta divided by cos theta, which is half divided by root 3 on 2. So you could type this into your calculator. However, I'll refresh you on how we would divide fractions. When you have to divide one fraction by another, you flip the second fraction and you multiply it. Okay, so whenever we're dividing one fraction by another, the second one flips and we change to multiply. We can see we have 2 at the top, 2 at the bottom will cancel, and we're left with 1 on top of root 3. So we can write it in a different colour around the outside of the circle here. The tan value here, 1 on root 3. The tan value here will be 1 because we have the same thing divided by the same thing. And of course we expect that for 45 degrees, right? If we have a 45-degree angle, if that's 90, that's 45, that's 45, they're the same size. We have an isosceles triangle. We expect x and y to have the same size, root 2 on 2. So the tan value is 1. Here the tan value will be root 3. Okay, keep going all the way around for the tan values. No, when you divide by 1, it would be root 3. This one stays as 1 on root 3. Oh, sorry, you're asking, is it the same as root 3 on 3? That's fine. Yes, you can express it like that. That's fine as well. Yep. Both of these are the exact
Do we
same.
have to calculate it as well?
On the outside of the thing.
On the outside, yep. Put the tan values in.
Are you going on camera?
It will.
The grin.
Alright, should we resume?
Yeah.
Yep. What have we been silly? Oh, you've already pressed resume. Thank you.
Oh! Don't put this on the...
Let's resume. Okay. So, let's resume. Alright. So, I think we're approaching the end. We've filled it in. We've got the tan values. Really good. So, let's just break down each of these quadrants, okay? So, just in terms of location, we describe this as the first quadrant, okay? And we're going anti-clockwise around the circle. This is our second quadrant, our third quadrant, and our fourth quadrant. Now, what I want to point out is that in this quadrant, cos is positive, sine is positive, and tan is positive. We say in the first quadrant, all of the trig ratios are positive. Okay, if we look at the second quadrant, in here, we have the y values are positive, but the x values are negative, and the tan values are negative. So in this quadrant, only the y values, only sine is positive. All right? In this quadrant, we have both x and y is negative. So cos and sine are negative, but the tan values are positive. And in this region, only cos is positive. Both sine and tan are negative. So that's important for us to remember. We have these different regions between 0 degrees and pi on 2. Okay, 0 radians, pi on 2. 0 degrees and 90 degrees. All of them are positive. Now there's a way to remember that. Okay, a little acronym for you. ASTC. All students talk. Cool. Okay, so remember that. Okay, let's have a look at, in your notes book, we've got a table there to fill in. We're going to talk about how we're going to fill this table in using the unit circle. So we have this table, it's got degrees, and then we're asked to fill in radians. Okay, so we've got 0 degrees is 0 radians. We've got 90 degrees. We can look at our unit circle. That's pi on 2 radians. We're also asked, I'll just talk to you how to fill it in, what's the sine value? Well, when the angle is 0, the sine value is 0. When the angle is 0, the cos value is 1. Alright? So we're going to go around our unit circle that we've filled in and fill this table in. That's enough from me, I reckon. The rest we'll be able to access in the textbook. So fill that table in, and then we can